Hi, I Dr. V. Priya, Associate Professor and Head, Department of Computer Technology. Today we are going to see about logical designs of IoT. Logical design of an IoT system refers to an abstract representation of the entities and processes without going into the low-level specific of the implementation. This diagram shows the functional blocks of IoT. IoT functional blocks provides the system the capabilities for identifications, sensing, actuation, communication, and management as shown in functional blocks of IoT diagram. Device. It provides sensing, actuation, monitoring, and control functions. Communication. It blocks communication block handles the communication for the IoT system. Services. Various types of IoT services such as services for device monitoring, device control services, data publishing services, and services for device discovery. Management. It provides various functions to govern the IoT system. Security secures the IoT system and by providing functions such as authentication, authorization, message, and content integrity and data security. Application provides an interface that the user can use to control and monitor various aspects of the IoT system. Allows the user to view the system status and view or analyze the processed data. IoT communication model. First one is request response communication model. Request response is a communication model in which the client sends request to the server and the server responds to the request. When the server receives the request, it decides how to respond, fetches the data, retrieves the resource representation, prepares the response, and then sends the response to the client. Request response is a stateless communication model and each request response pair is independent of other. This diagram shows the request response communication model. Second one, publish subscribe communication model. Publish subscribe is a communication model that involves publisher, broker, and consumer. Publisher are the sources of data. Publisher send the data to the topic which are managed by the broker. Publisher are not aware of the consumer. Consumers subscribe to the topic which are managed by the broker. When the broker receives the data for the topic from the publisher, it sends the data to all the subscribed consumers. This diagram shows the publish-subscribe communication model. Next one, push-pull communication model. Push-pull is a communication model in which the data producer pushes the data to the queues and the consumers pull the data from the queues. Producer do not need to be the aware of the consumer. Queues help in decoupling the messaging between the producer and consumers. Queues allow act as a buffer which helps in situation when there is a mismatch between the rate at which the publisher push the data and the rate at which the consumer pulls the data. This diagram shows the push-pull communication model. Next one is exclusive pair communication model. It is a bidirectional, fully duplex communication model that uses a persistent connection between the client and the server. Once the connection is set up, it remains open until the client sends the request to close the connection. Client and server can send the message to each other after the connection setup. Exclusive pair is a stateful communication model and the server is aware of all open connection. This diagram shows the exclusive pair communication model. IoT communication APIs. REST-based communication APIs. Representational state transfer is the set of architectural principle by which you can design the web services and the web apps that focus on the system resources and how resource states are addressed and transferred. REST APIs follow the request response communication model. The REST architecture constraints apply to the components, connectors, and data element within a distributed hypermedia system. This diagram shows the IoT communication apps of REST-based communication API. The REST architecture constraints are as follows. Client server. The principle behind the client server constraint is the separation of concern. Client should not be concerned with the storage of data, which is a concern of the server. Server should not be concerned about the user interface, which is the concern of the client. Separation allows the client and server to be independently developed and updated. Stateless. Each request from the client to server must contain all the information necessary to understand the request and cannot take advantage of any stored context on the server. The session state is kept entirely on the client. Catchable. Catch constraint requires that the data within the response to the request be implicitly or explicitly labeled as catchable or non-catchable. If the response is catchable, then the client catch is given the right to reuse that response data for later equivalent request. Layered system. Each component cannot see beyond the immediate layer with which they are interacting. Uniform interface requires that the method of communication between the client and server must be uniform. Resources are identified in request, that is URI, and are then themselves separate from the representation of the resource that are returned to the client. Code on demand. Servers can provide executable code or scripts for the client to execute in their context. So, the RESTful web service in web API implemented using HTTP and REST principles. REST is the most popular to IoT communication APIs. WebSocket based communication APIs. WebSocket APIs allows the bidirectional full duplex communication between client and server. WebSocket follows the exclusive pair communication model. Unlike request response models such as REST, the WebSocket APIs allows the full duplex communication and do not require new connection to be set up for each message to be sent. WebSocket communication begins with the connection setup request sent by the client to the server. The request is sent over HTTP, that is called WebSocket handshake, and the server interprets it as an upgrade request. If the server supports the WebSocket protocol, the server responds to the WebSocket handshake response. After the connection setup, client and server can send the data or message to each other in full duplex mode. WebSocket API reduce the network transfer and latency as there is no overhead for connection setup and termination request for each message. WebSocket suitable for IoT applications that have low latency or high throughput requirement. So WebSocket is the most suitable for IoT communication APIs for IoT system. This diagram shows the exclusive pair model used by WebSocket APIs. Thank you.